Hi, my name is Alexander Steinmaurer and I'm a university assistant and PhD student at Graz University of Technology in Austria. My research focuses on computer science education, engaging learning technologies, and computational thinking. Together with my colleagues David Eckert, Julius Treveni, and Christian Güttel, we worked on a multiplayer game mode in a programming learning environment. In educational and professional settings, many collaborative approaches for coding already exist, such as programming workshops, hackathons, or pair programming. These methods can increase the skills, creativity, productivity, and diversity of development teams. In previous evaluations, students stated that collaborative gaming approaches would be motivating for them. Based on this feedback, we designed and implemented a multiplayer game mode for our sCool game environment. We defined the following research objectives. How do students communicate in teams while collaboratively solving a programming task in the multiplayer game mode? What are the opportunities and challenges related to the players' interactions within the game? And finally, how does the multiplayer game affect the students' attitude towards collaborative learning? An important element in computer-supported collaborative learning is the communication between team members. Fast-paced communication technologies, such as a chat, promotes instant communication. Related to this aspect, an explicit goal is vital to have a clear aim for all team members. But research also showed that the text messages in a chat could have an impact on programming tasks since both use text as a medium. There are many different serious games with a dedicated multiplayer setting. Coding game is a platform where players are challenged to solve tasks against each other. There is no interaction between players during the tasks, but the platform provides an asynchronous communication where players can discuss solutions after a challenge. One immersive video game is Funplugs, where players create and solve puzzle-like programming tasks. This game consists of two scenes, a building and a scripting scene. With a building scene, students are collaboratively creating levels together, where one person is using a desktop view and the other person is wearing a VR device. sCool is a platform for computational thinking, in particular for coding. It consists of a video game and an online platform for educators. Educators can individually define the levels for their students. The game has a concept learning part where students learn basic ideas and concepts, and the practical part where students can train their skills in a programming environment. Based on previous evaluations, we plan to develop a collaborative game mode where students can play and learn with each other. They should be able to solve the programming tasks together by coordinating each other. We formulated different requirements that multiplayer mode should compromise. First, various game elements should be included that promote collaborative learning. A central aspect of the game mode should be the communication between players, therefore an in-game chat communication should be supported. To receive a flexible and individual learning environment, educators should have the possibility to create multiplayer maps. Communication and interaction between players are vital parts of a collaborative multiplayer environment. The design of the gameplay requires communication between players to discuss strategies to solve a given puzzle. Therefore, we provided the players with an in-game chat. The chat can be used globally, which means for all people enrolled in a course, or locally for all players within a level. Doors and triggers are simple game elements to motivate a collaborative setting. Triggers are represented as a platform that can be located on an empty field on the map and must be activated by moving over it to open a certain door. In the online custom map creator, doors and triggers can be placed individually on the map. The idea of wait and signal is to introduce the players to the concept of concurrency. Just like threads in computer science, the robots are able to work through their tasks concurrently. There might be a point where one player has to be sure that another player has completed a certain task before moving on. This could be a certain path that is just available for one person at a single time, or triggers that have to be activated at a certain time. The additional game mode is emphasizing on strengthen and efficient communication between players where they communicate about their strategies. Students should be made aware about common problems in computer science, such as concurrency. And additionally, the game mode develops the students' coding and computational thinking skills. The system consists of the sCool game, which is available for Windows and mobile devices. All game-related data, such as level information or learning data, is transmitted to the web application. All communication, such as the chat messages, are transmitted via a WebSocket connection to the server. All the data is stored in a MySQL database. The study was conducted in 3 groups with 41 participants in total. 2 evaluations were conducted in classroom and 1 as a full online study. Overall, the activity lasted 50 minutes, whereas 40 minutes were reserved for playing the game. Overall, the participants could solve 9 levels, whereas it was mandatory to solve at least 6 before answering the questions in the in-game questionnaire to have a broad idea about the game and its mechanics. The study took place in 3 groups, Group A and B, as in-class activities in 2 different secondary schools. Group A, a 3rd grade secondary school in a rural area with 19 students, and Group B, a 7th grade secondary school with 13 students. The evaluation of Group C was planned as a dedicated online study with computer science students from Graz University of Technology with 9 participants in total. At the end of the evaluation, the participants were asked to fill out a survey with 24 items in total. The answers were collected using an in-game questionnaire that is integrated into the game's user interface. The survey consisted of 4 parts. First, personal information such as age and gender, collaborative learning, system interaction, and last, final, general feedback. The questions related to collaborative learning are a modified version of Driver's questionnaire, including 11 questions. Due to the specific classroom situation of this study, we defined 6 questions to receive insights about the students' interaction with each other. Finally, we asked students for open-ended feedback. Even though the mode of the workshops slightly differed from each other, the procedure was the same for all of them. All interventions took a total time of maximum 50 minutes. First, all participants received an introduction about the evaluation and the game. In both in-class activities, this explanation was held by a member of the project team. At the online workshop, the participants received all necessary information via a YouTube playlist. The students were provided with 9 levels in total. The players randomly joined the lobby, which means they were not aware who is in the same level. The tasks differ in the level of interaction necessary to solve them. The majority of the participants stated that they enjoyed playing the multiplayer mode with a mean of 1.86 and a standard deviation of 0.77. Using a correlation matrix of all variables, we figured out that students feel strongly as part of a team when they have a high level of communication and a frequent communication. In the open-ended section, a student answered, "I liked the possibility to exchange within the chat and that I had to trust the other blindly if he did not answer in the chat." In total, 317 messages were sent over all 3 evaluations, with the majority of all messages in Group C. Since the group was planned as a full online study, there was also online communication, for example using Discord or other tools. Especially the students of Group C answered that they had some issues with the chat, and some mentioned that they would prefer an easier communication channel. Finally, I can say that the students enjoyed working with the multiplayer game mode. The design of the levels promotes a collaborative setting where all players have to participate actively in finding a solution. The communication using the chat worked well, but also showed some room for improvements in usability. For future work, we plan to improve the chat's functionality to make some actions easier, such as pointing on certain elements. We also want to include more game elements that promote still more collaboration, such as pressure plates. We also want to extend the study for a larger population.